Hello, this is going to be our first mathematics lesson. It's going to be on how to use matrices to solve systems of linear equations. So our team is made up of Martín Dieck and Jaime Guzmán, and here we're going to start with the lesson. So first, to start, we're going to review what are linear equations. So a linear equation is an equation for a straight line. That's basically it. So now we're gonna examine the formula that it follows, which is y equals mx plus b, where y is equal to the dependent variable, and it is dependent on x, which is the independent variable. And then m is equal to the slope of the equation, while b is equal to the y-intercept of the equation. So now an example of that linear equation would be y equals 4x plus 5, where 4 is the slope of the equation, 5 being the y-intercept, and the x and the y is the variables that we have on the graph. So what is a matrix? In mathematics, a matrix, which is plural is matrices, is a rectangular array of numbers, symbols, or expressions arranged in rows and columns. Now you might be wondering, what is this arrangement of numbers for? So basically, matrices can be used to write and work with multiple linear equations, that is, systems of linear equations. So as we can see this example right here, this is the matrix we're going to be working on. So this matrix, as we can see in the first step of solving the systems of linear equations, we need to fill in the matrix. As we can see, in the equations on the left are now basically filled in on the right. So the 4x would be equal to a 4, the negative 3y would be equal to a negative 3, the positive 2c would be equal to 2, the 11 would be equal to 11, and so on. So basically we need to fill out the numbers and ignore the variables for now in order to really solve the matrix. So the step 2 in solving the matrix will be to find its reduced row echelon form. So this is the form that gives you the answer to the systems of equations. So you need to, after you fill it, turn it into this form. And we're going to see how. It's a series of steps. And basically, once you get this form, you have completed the problem. So we're going to see the series of steps that we need to follow in order to get to this form. So how do we find this reduced row echelon form? We use a combination of custom row-based formulas. What does this mean? We need to either transform a number into 1, or we need to transform a number into 0. So to transform a number into 1, we need to divide the whole row by the same number, thus making that number into a 1, but modifying the rest of the numbers. Let's see this example. For example, if we want to turn the first number, which is a number 4, into a 1, we need to divide the whole row by 4. As we can see, row number 1 is being divided by 4, so the 4 turns into a 1, but the whole row is affected. As you can see, the negative 3 became a negative 3/4, the 2 became a 1/2, and the 11 became 11 over 4. So the whole row was divided by 4, and this turned the number into 1. To make a number equal to 0, we need to multiply another row that has a 1 on the same column, and then multiply it by a negative of the same number, and then add both columns. So this might sound complicated, but it is actually quite easy. For example, we're going to turn the 9 into a 0. So in order to accomplish this, we're going to multiply the third row, which is a 1. This is very important. We need a 1 on the same column in order for it to work. So we multiply the third row by negative 9 in order to cancel out that 9, and then we add it. But this means for the whole row. So we're not just multiplying the first one, we're multiplying the whole row and adding it by the row on the top. So for example, the 9 turns into 0, but then if we add negative 9 times 1, it's negative 9, plus 2, it's negative 7. And the same thing goes for the rest of the numbers. So this is basically it. Now we're just going to see the order of operations in order for the end result to look like this. So for example, the end result must always look like a right triangle of ones surrounded by zeros. What does this mean? It basically means that the right triangle should be like a sort of pyramid of ones, but then we should have zeros all around. Now to accomplish this, we must follow a specific order. You must start with the top number of the first column and move downward. And after you finish that first column, you move on to the second number on the second column, so on and so forth. For example, we start with the 1, then move downwards, and when we finish the first column, we move into the second column, and then when we finish the second column, we move into the third column. And this is the order that we need to follow in order to achieve the row echelon form. So now we're going to finish the example that we said previously. Let's begin. So we have this matrix right here, and we need to turn this number into a 0. So in order to do it, we need to multiply the first row by a -1 in order to cancel out the 1, and then add it to the third row, which is what we did right here. And then we transfer this matrix onto here, and then we need to turn this number into a 1. So in order to turn it into a positive 1, we need to divide the whole row by a -7, which is what we are doing, thus turning it into a 1 and dividing the whole row by a -7. Then we need to turn this 7/4 into a 0. So we need to multiply the second row by -7/4 in order to cancel out the 7/4 that we have in the third row. And then we add both of the rows in order to turn it into a 0. Now we need to turn the -2 into a 1. So then we divide the whole row by a -2, thus giving us the 1. But it is the whole row, remember. So the -6 is also divided by the -2, which is +3. Let's continue. So now that we have this matrix right here, we need to turn the -3/4 into, we need to turn the 10/7 into a 0. So we need to multiply this row right here by a -10/7 and add it to the second row, thus giving us a 0 and the 1 right here. This is very important. We'll see later on why. So now that we have a -3/4 in here, which we need to turn into a 0, we need to multiply this row by +3/4 and add it to the first row, thus giving us a 0 right here, a 0 right here. We just need to turn this one to get the final form. So to get this form, we need to multiply the third row by a -1/2, add it to the first row, and then we get the final form. Now you might be wondering, what does the final form mean? So the final form gives you the answers to each of the variables. As we can see, the final column is different than the rest of the matrix. This is because the final column is actually equal to all of the variables. As we can see, this one represents x, and then this number represents the value of x. So x is equal to 2, y is equal to 1, z is equal to 3, thus giving us the answer to this system of linear equations. Now, can we use matrices on a larger scale? The answer is yes, but just remember, you have to follow the same number of formulas as you have variables. For example, in this matrix, we are using 4 formulas in order to solve for 4 different variables. So this is going to be the answer for each of the variables, and you always have to keep that same ratio. So you may use a 2-number matrix, but you need to use 2 formulas. Or you may use a 28-number matrix, but you need to use 28 formulas to solve for 28 variables. I hope you got the whole topic clear and you may use this for your future knowledge. Thank you very much, and I hope you guys have a really nice day.